A mysterious visitor has swept through our solar system, rewriting the rules of cosmic behavior and sending ripples through the world of astrophysics. The object, known as 3I Atlas, is an interstellar comet hurtling through space at breathtaking speed and displaying behaviors that defy scientific expectations. Among its most astonishing traits is an apparent bending of the solar wind, the constant stream of charged particles flowing outward from the sun. While comets have long been familiar to astronomers, this one carries an unmistakable air of the alien, something born beyond our sun's influence and acting in ways that challenge established understanding. The bending of the solar wind around it has drawn the attention of scientists worldwide, who are now puzzling over what mechanism could cause such a phenomenon and what its broader implications might be. I-Atlas was first detected in early July 2025 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile. Its motion was extraordinary, faster than any previously observed interstellar object, and its trajectory was clearly hyperbolic, confirming that the sun is not its home and that it will eventually escape our planetary system entirely. What began as the discovery of a rare interstellar wanderer soon became far more intriguing when astronomers reported that 3I Atlas appeared to be influencing the solar wind in unprecedented ways. Rather than being simply buffeted by the wind, as most comets are, it seems to be bending and redirecting its flow, creating a complex interaction zone that has left scientists questioning how such a small body could have such a profound impact. To understand the magnitude of this discovery, it's important to recall what the solar wind is and how comets typically behave. The solar wind is a continuous stream of charged particles, mainly protons and electrons, emitted from the sun's corona. This plasma carries the sun's magnetic field throughout the solar system, shaping planetary magnetospheres, fueling auroras, and defining the heliosphere, the vast bubble that envelops all the planets. Normally, when a comet enters the inner solar system, sunlight heats its icy nucleus, causing volatile ices to vaporize and form a glowing coma of gas and dust. It usually develops two tails, a dust tail pushed away by radiation pressure and an ion tail carried along by the solar wind. In these cases, the comet is passive. It reacts to the solar wind but does not influence it. Atlas, however, seems to be breaking that rule. Instead of being shaped by the solar wind, it appears to be shaping the wind itself. Observations have revealed dust emissions from its sunward side and tail structures that do not align in the usual direction away from the sun. In fact, there is evidence of a plume directed toward the sun, and reports indicate dust being ejected sunward, the opposite of what we would expect. This bizarre behavior, coupled with the apparent bending of the solar wind, suggests a complex magnetic or plasma interaction at play. It's as if the comet is creating its own field of influence, forcing the solar wind to flow around it rather than simply past it, much like a boat generating eddies and waves as it moves through water. Several hypotheses are being discussed to explain this. One possibility is that 3I Atlas possesses an intrinsic or induced magnetic field that disrupts the solar wind around it. If its surface contains conductive materials or charged dust, it could set up magnetic perturbations strong enough to divert nearby plasma. Another theory suggests that its outgassing is unusually powerful and directional, injecting ionized material into the solar wind and creating a local shock zone, similar to a miniature magnetosphere. Together, these interactions could produce a bow shock that alters the trajectory of the wind. Adding to the mystery is the comet's likely origin and age. 3I Atlas appears to have traveled through the galaxy for billions of years, possibly between 3 and 14 billion, older than our sun itself. Its hyperbolic trajectory suggests it was ejected from another star system long ago and has been exposed to cosmic rays and interstellar radiation ever since. Its unusual chemistry, including elevated levels of nickel and cyanide, indicates a composition shaped by vastly different conditions. These exotic materials could explain its strange electromagnetic behavior and interaction with the solar wind. If 3I Atlas truly bends the solar wind, it challenges the long-held assumption that comets are passive participants in the heliosphere. Instead, it would suggest that small, fast-moving bodies can significantly perturb plasma flows, a finding that could rewrite parts of heliophysics. Studying how the solar wind reacts to this interstellar object provides scientists with a natural laboratory for understanding plasma interactions, magnetic reconnection, and dust charging in space. The insights gained could even improve our understanding of how the solar wind interacts with planets like Earth and Mars, or how similar processes might occur around other stars. This discovery also deepens our grasp of interstellar materials. If bodies from other star systems interact with solar winds more strongly than our native comets, it could imply that planetary formation elsewhere yields very different types of small objects, perhaps more metallic, porous, or electrically active. The sunward dust plume seen on 3I Atlas further suggests that sublimation on its surface is unusually concentrated, possibly forming a focused jet of material that pushes against the solar wind, creating a local engine effect. The combination of outflowing dust and streaming plasma may be redirecting the solar wind around the object, producing a distortion that current models cannot explain. The comet's immense velocity also plays a role. Traveling far faster than typical solar system comets, 3I Atlas interacts with the solar wind in a high-energy regime. The relative speed is so great that it may generate bow waves and compressed plasma regions, forcing the solar wind to bend dramatically around it. This supersonic interaction amplifies the disturbances, making them more visible and scientifically valuable. If confirmed, this event would fundamentally alter how we think about interstellar objects. It would suggest that such visitors are not inert travelers, but active participants that can reshape the environments they pass through. This has implications for space weather modeling and for how we prepare to study future interstellar bodies. By observing how the solar wind bends and changes around 3I Atlas, scientists can infer valuable details about its magnetic field, composition, charge, and internal structure, offering a new way to study distant objects without landing on them. Over time, many interstellar objects like 3I Atlas may have entered our solar system, subtly influencing the heliosphere and leaving traces in the form of disturbed dust and plasma trails. Each visitor becomes a messenger from another world, offering glimpses into the conditions and materials of faraway star systems. The bending of the solar wind may seem small on a universal scale, but it symbolizes the profound interconnectedness of cosmic forces. Our solar system, once thought to be a closed bubble of the sun's influence, is in truth a permeable region that engages dynamically with the galaxy around it. This extraordinary encounter also highlights the need for better observational capabilities. Capturing such phenomena requires more than telescopes. It demands spacecraft equipped to measure plasma, magnetic fields, and dust directly. The case of 3I Atlas shows how closely intertwined astronomy and space physics have become. Its behavior blurs the line between cometary science and plasma physics, between heliospheric studies and interstellar exploration. From a philosophical standpoint, the story of 3I Atlas is humbling. It reminds us that the sun's domain, vast as it is not isolated from the galaxy. Foreign wanderers can enter our system and bend the very wind that defines it. The event invites us to rethink the solar system as an open, dynamic crossroads, a place where external forces and interstellar travelers engage in a silent cosmic dialogue. Future missions may now prioritize intercepting such interstellar visitors to study them up close, armed with instruments capable of probing their plasma interactions. Ultimately, the bending of the solar wind by 3I Atlas is more than a curiosity. It's a revelation. It challenges what we thought we knew about comets, plasma physics, and the boundaries of the sun's influence. The solar wind, once seen as an unstoppable outward flow, is shown to be vulnerable, capable of being bent and redirected by a small, ancient traveler from another star. In that astonishing interaction lies a reminder of the universe's complexity and the constant exchange between worlds, stars, and systems. 3I Atlas, in its brief passage through our neighborhood, has left not only a trail of dust, but a lasting question about how the cosmos truly connects.